Hello guys, welcome to Math Frontage. So in this lesson we are going to talk about the fundamental theorem of calculus part 1, right? So we are going to do more examples in this video so that you can see the strategy and also to see how easy it is to solve these types of questions, right? So the first thing that you need to know is that g of x is equals to the integral from a to x f of t, right? And then again, just know that a is the first limit or point, and then x is the second limit, right? Just keep it that way. And then again, you need to know that the derivative of the integral from a to x of f of t dt is equals to f of x, right? So example 1, use the fundamental theorem, use the fundamental theorem, um, use the fundamental theorem to find first quotient u over dx integral from 1 to x to the power of 4 secant of t dt. So before we can even go further or solve this question, guys, you just have to know that in the fundamental theorem of calculus part 1, most of the time you will not be told or you'll not be given the statement like this one that you need to use the fundamental theorem to find this question, like to solve this question, right? So, but then you just have to know by looking at it that this one surely it is the fundamental theorem of calculus part 1. How so? Most of the time, these questions are going to have d over dx before the integral, right? After having d over dx before the integral, remember d over dx is the derivative. Sometimes they might use this one, so you also have to be familiar with it. And then after writing the integral, you can see our bonds or the limits, it's 1 and x to the power of 4, right? So as it's x, right? Then now check the function that you have. You can see the functions is in terms of what? Of t. So most of the time the functions in the fundamental theorem of calculus part 1 is always in terms of t. So but then the basic idea behind part 1 of the fundamental theorem is that we mostly replace t with x. Sometimes they might put b. So it means that we mostly replace b with what? Uh, t with b, right? So that's how you're going to know that no, this one is the fundamental theorem of calculus part 1. So now let's do the solution. The solution, letter A, u over dx integral from 1 to x to the power of 4 secant t dt, right? So the first thing that you need to do is to differentiate the second bond. Also, you're going to say u over dx into x to the power of 4 because it's the second bond. Therefore, after you multiply it with the function that you have. So you can see the function that we have here, it's a secant. But then where we see t, we are not going to write it. We are going to replace with the second point or the function or the limit that we're going to differentiate, which is the second point, right? Which is x to the power of 4. Then we are done. After writing it down like this, then now we are going to the first point. But then before we go to the second point, we need to subtract. It means you're going to put the negative sign, and then we do the same thing that we did in the second point. It means we're going to differentiate the first point. It's going to be d over dx into, we differentiate the first point, which is it's 1. We close the bracket. Therefore, it's the function we're going to multiply it with what? The function that we have, it's secant. Where we see t, we're going to replace it with the first point, which is 1, because we're focusing on the first point, right? That's how we do it. Then now, what is the derivative of x to the power of 4? It's 4x cubed, right? Multiply by the secant of x to the power of 4 minus, what is the derivative of 1? It's 0. Multiply by the secant of 1. So we know that anything which we multiply it with 0, it's going to give us 0. Any number, whenever we multiply it with 0, it's going to give us 0. So it means our answer is going to be 4x cubed multiplied by the secant of x to the power of 4. This is how we solve the first question of the fundamental theorem of calculus part 1. So now let's do the example 2. Okay guys, here's the second example. So that you can see that we are not told what we should do, but then we're just given d over dx to the integral from a to 2 cosine of t squared dt. Like I said, if you see this type of question, just know it's the fundamental theorem of calculus part 1. So, solution, we do the same thing that we did in the first example. What is the first thing that we do? You can pause the video and try it. What is the first thing that we do? We differentiate the second point, right? It's going to be d over dx. What is the second point? Is 2, or the second limit. Then after we multiply it with what? With the function that we have, which is cosine of t. We replace it with the second point. It's going to be t squared. Can you guys see it? Then after getting done with the second limit, what do? We put the negative sign. Then we do the first limit. Then we're going to differentiate the first limit, which is x. Then we multiply with the function. Where we see t, we're going to write the first limit, which is x. It's going to be x squared because there is a 2 here. There is a square here, right? Then now we're going to differentiate. The derivative of 2 is what? It's 0. Multiply by cosine of 4, because 2 squared is 4, right? Minus, what is the derivative of x? It's going to give us 1. Multiply by cosine of x squared, right? So 0 multiplied by cosine of 4 is going to give us 0. Therefore, we'll be left with negative cosine of x squared. Can you guys see it? This is how we solve these types of questions, right? So let's do more examples. Now let's do maybe difficult questions and see how can we solve them. I'm just going to erase these things here. Okay guys, so here's the other example. So you can pause the video and try to do it. So now let's find the solution for this problem. Solution. We're going to follow the same steps that we did in example 1 and 2. So it means we're going to differentiate the second point. It's going to give us d over dx into the second point is what? It's x. Therefore, multiply by that function that we have where we see t, we're going to replace it what? With the second point, because we are dealing with the second point. It's going to be x squared plus 4. Can you guys see it? Therefore, now, because we are done with the second point, we're going to put the negative sign, then deal with the first point. We do the same thing as d over dx into function which is, or the first limit is 0. Therefore, multiply by the function is 0 squared plus 4. Can you guys see it? The derivative of x is 1. Multiply by the function that we have, which is square root of x squared plus 4. Therefore, minus the derivative of 0 is 0. So meaning we're going to have 0, meaning the final answer is x squared plus 4. So I want you guys to check something. So if you can check this function here, it's the square root of t squared plus 4. Can you guys see it? And if you can check this one here, it's the square root of x squared plus 4. So you can see that we replaced t with what? With x, right? So, but then you need to show the steps when you do these types of questions. But then if there was x squared here, let's say if there was x squared here, what was going to be our answer? Okay, let's do it here in the shorter step. Let me show you something how this easier it is. Let's say 0 to x squared t squared plus 4 t, right? So what are we going to do here? We are going to differentiate this one x squared, right? Therefore, we're going to get 2x multiply by, therefore we write everything that is in the function. Therefore, we can see that is t. Therefore, we're going to replace t with that x. It's going to be x squared multiplied by 2 because there is a 2 here, plus 4, right? Remember, we're still dealing with what? With the second point, right? Therefore, now we're going to say minus, what is the derivative of 0? It's 0. So meaning there won't be any function here. So we just write 0. Therefore, it means we're going to have 2x into x to the power of 4 plus 4. This is how guys we do it. But then don't use this step because you're going to forfeit marks. So I prefer you to use this step that we were doing. So let's do the last one, which is more complex. Example 4. Okay guys, so these are the examples you should try, and after finding the answers you can write them on the comments below so that I can check them. And then if you found confident that you got them, that's correct, you can do all those from A to C. Thank you. That's it for this lesson about the fundamental theorem of calculus part 1. If you don't forget to subscribe guys, please. Thank you.